Good morning, and welcome back to middle school science classroom. My name is Mr. Paul, and I will be your teacher again today at the wonderful Sequoyah Public Schools. Today we're going to move into energy. We had a small video to start with, but we had some technical difficulties, so we're going to move on past that, and that'll be okay. So the first thing we have to figure out is potential and kinetic energy. What are they? Well, we'll find out soon. Okay, so there's different forms of potential energy. You have gravitational, which think of an apple falling out of the tree, Newton's law. Dropping a basketball, especially in your mom's house when she gets mad. Gravitational potential energy right there. Means it has the potential to have energy. Then you have elastic energy. When you shoot that rubber band across the classroom when you're told not to, or you're even jumping on the trampoline right now at home, that's elastic potential energy. Then you have magnetic potential energy. I am out of the view. My apologies. Okay. Then you have chemical energy, which is a wide variety of different ways of doing it, which we'll talk about in a minute. Electroelastic energy, which is one of your probably favorite ones, is when you're running through the house and you're pulling your feet across the carpet and you run up and shock your sister. That's elastic energy right there. And then we have nuclear energy, which we have several different types that we'll talk about when it comes to nuclear energy. And then the opposite of potential energy is kinetic energy, the actual doing. So we have mechanical, which you're going to see a lot in turbines, fans, movement, which we're going to talk about when we go over to the roller coaster in a second. Then you have electrical, which is probably one of your favorite. So you can plug up your iPads, your PS4s, and all those electronics. Thermal, anything that produces heat, so you can cook your food, have a campfire, anything along those lines. Your electromagnetic, your lights. And then one of the ones we forget about the most is sound, which we're going to have a demonstration a little bit to show exactly what sound can do. So, forms of energy. What is energy? It's to be able to do work. So a good example of saying this is when your mom makes you go outside and do some yard work. You go out there and you sit there and stand and you look at sticks when you're supposed to be picking them up. You have potential to pick up those sticks. When you're actually moving to pick up those sticks, you have kinetic energy. You're actually doing the work. So the majority of energy that originates from the sun in the form of fusion. There are many different forms of energy, which we just talked about. And the easiest strategy to remember this is Mr. Sense. Now, we're not going to go over all of these, but we're going to discuss them soon. So you have mechanical, radiant, chemical, electrical, nuclear, and thermal. So the video that I had earlier before we get into all the way into mechanical is we had a roller coaster. Now, we all are ready to get out of the house, and I figured we'd start with that, but technical issues will be aside. So the best way to demonstrate this is simple. So me and my son love to create and build things. So one of the things that we build is a marble roller coaster. So what you're going to do, simply just watch. So when the marble is at the highest point, it has the most potential energy. And as it moves down the track, it's going to start converting the potential energy into kinetic energy. Now, if this track was all the way down at a very sharp angle, the kinetic energy would pick up faster and the potential would go away. As it goes all the way down, kinetic energy picks up, potential decreases until it gets to the bottom, where it has little potential energy. Now, mechanical energy has to do with the position and how it moves. In saying that, there's also different forms of mechanical energy. First one I think of is spinning gears. This is the one that we always show. So on the back side of this marble roller coaster, we have sets of gears. Now what these gears do is they rotate to allow to pick up an object so that it can take it to the top and drop the marble down to start the process over. So mechanical energy has potential and kinetic energy. It's a combination of the two. Another great example of this is if you go towards Kansas or out west, you see a whole bunch of windmills. We use windmills to create energy, clean energy, renewable energy. Another one is when you're riding your bicycle out with your friends. Those gears you're pushing to help make it easier for you to go faster So you're using your mechanical energy as your body, and then using the gears to produce more kinetic energy, which is easier on you. Then we have radiant energy, your lights. You have different types. You cannot see these. They travel in waves, just like another one that we're about to talk about. But before we go into that, your television, your gaming systems, Wi-Fi, all of those fundamental things that you're using probably every day, especially if you're doing virtual learning also. Traffic lights also use this. And your favorite one, cell phone. Give me a second. Oh, hello? Sorry, give me 1 second, guys. Yes. Okay. That was your other teachers. They're making sure you're staying up with your work. This is a form of electromagnetic energy right here, though. Every time you use that cell phone to send messages or receive them, make phone calls, maybe your boyfriend or girlfriends, or maybe your crushes, any of that. Electromagnetic energy, or your radiant energy, I'm sorry. Then we have chemical energy, which is stored in energy in the molecules, which is potential energy, as we discussed earlier, until it has a chemical reaction and creates kinetic energy. Now, involved in chemical reactions take place, forms of potential energy occurs because it's in the bonds of the atoms, and then when the chemical reaction occurs, you have the energy. So, great example is food. Everyone in here ran to get some cookies earlier, so they've already started this process. They're breaking down those chemical bonds in food to create energy for their body. Coal. In Oklahoma, we use a lot of coal, natural gas, and oil. We kind of run on it. So that is also a form of chemical energy. And then anytime you store it in batteries, you have potential energy. So one way of showing this is, you've probably done this before, is baking soda and vinegar. If you haven't, you're about to see something new. But to show the change of energy in the chemical reaction, we're going to use vinegar, baking soda, and a balloon. Lovely sound. Okay, so I'm not going to measure anything out. Just remember, the more baking soda and vinegar you use, the better the chemical reaction is going to occur. You have a base in the baking soda, and then you have an acid in the vinegar, which is going to cause a chemical reaction. But we're going to focus on what comes out of it first. What am I doing? I need that back up there. I got to be quick about this one. Okay, so if you noticed, the gas pushed up and caused the balloon to inflate. But why did this occur? Because a chemical reaction took place and the base and the acid reacted together to create carbon dioxide. Now there's also another thing. If you've ever done elephant toothpaste, which we did this year in my class, you'll notice that the reaction causes a lot of heat. Well, in this one, it does not. It actually becomes very cold. This is an endothermic reaction. It actually pulls in the heat, creating a cold vibe out of the vinegar and solution of baking soda. And saying that, though, I remove it, all the carbon dioxide gas is gone, and then I'll put the balloon back on to show that the chemical reaction actually caused the gas to expand. No more carbon dioxide in the balloon. Okay, so that's one simple way of showing a chemical reaction. There's a lot of other ones. Like I said, elephant toothpaste would be a great example of this. Okay, it does take a few more ingredients, especially right now with all of the salon shops being shut down. Actually, they just opened back up to get some of the chemicals needed to use in it. So the next one that we're going to talk about is electrical energy. Like I said earlier, this is all of your devices. How we're running the computer system right now, all of our lighting, all offers electrical energy charges. So electricity is many different objects in our daily lives. Electricity fits in our homes since the 1800s. Examples of this would be lamps, electrical outlets, and chargers. And like I said earlier, static electricity is one of them too. But since we don't have carpet in here, and I'm not going to run around in my socks and try to generate it, I'm going to do it a different way. Now, if I can learn how to tie correctly. So what's another way? assuming we all have played with balloons before. And yes, I have an abundance of hair right now, so this will work out perfectly. So all you have to do is rub it back and forth, making the electrons and the positive neutrons face back and forth, creating static electricity as my hair goes up. Now, hopefully this will be cut tomorrow since the shops are back open, but that's just a way of showing that there's different forms of electrical energy currents, especially when you can't see them. Okay, so our next one is nuclear energy. Actually, 10% of the world's energy comes from this. There's good things that occur from it and bad things. One of the number one things that you have, as I said earlier, was the sun. Nuclear fusion is occurring. If you go outside and enjoy and soak up that sun, you'll actually be having some nuclear energy upon yourself. So, nuclear fission, on the other hand, is splitting of atoms. We use that in nuclear facilities to create and generate clean, substantial energy, whereas fusion, like I said, was part of the sun. So examples of this would be fusion for the sun, power plants for fission, atomic bombs, which we're not going to focus on the atomic bomb portion. We're actually going to focus on the nuclear power plants portion. So one way of showing you how to do this is, so in power plants, even though the technology is continuing to get better every day, since a lot of the technology that is outdated, so more and more nuclear power plants are actually being created. I read an article the other day that said 136 new ones are being created this year, or actually informed to create. So how it works, though, is you have a fuel source, uranium typically, and it goes down in a fuel rod with a couple other things, and then you have large amounts of neutrons that hit it. So this uranium rod is in the middle of a water substantial, and it heats up the water. That's actually how we create the energy from it. Now, earlier I said that there's positives from it, and there's a lot of negatives too. So a few of the negatives would be if we had a nuclear disaster. Japan had one in 2011, I believe, or 2012. And then one of my favorite ones that my teacher right across from me likes to talk about is the Chernobyl disaster. So what happened there is the core actually came out of control down. So that's also one of the negatives that occurs with nuclear energy. So the other part of it, though, is as a byproduct. So when the nuclear core is in the middle, it also sits and creates. So I'm just going to sit there and let it float. Miss Bacon? Yeah. Will you grab those scissors that I forgot over there? Yeah, those will work. So what happens is when the uranium rod is in there, it also produces a byproduct because the water actually becomes radioactive. So it's almost like breaking another glow stick and it melting down in there. Now, as it goes in, this is the byproduct that occurs. Now, the problem with this is we can't use it after this. Now, a lot of countries are starting to try to use this byproduct and reuse it in the fuel source, but it's very hard to do. So what we have to do is we actually have to take this radioactive water or byproduct and we bury it miles within the earth because it's very radioactive. So, again, it produces a lot of clean, substantial energy, but two tremendous negatives that can occur from it would be a nuclear disaster and the byproduct of the radiation. So that's just an example of that as we go through it. So another one is thermal energy. Perfect. Earlier we used it to cook cookies. They smell delicious, by the way. And then it also heats up the atoms and particles to move faster. So earlier we had an endothermic reaction, which actually cooled it. But when I said the elephant toothpaste actually causes heat to speed up the particles. Now, hot, more, cold, less, as I just discussed earlier with the two experiments. So, iron heats up, a toaster, and fire. So, another example is just simply this. Simple match. That's all we're going to use. That is a chemical reaction that occurred. Have heat that is produced from it. Now, if we're not in my room, I don't want to set off any fire extinguishers, so we're going to get rid of that real quick. But that's just a simple example of how that chemical reaction occurs, and it can also produce a heat, which we use. So again, when we burn coal, one of the process of that is heating up a source to produce the electricity. Same with the nuclear fission portion in a power plant. So sound energy. Energy that vibrates matter. Sound can travel through solids, liquids, and gases. So examples of this, your blowhorn. So when you're all out at the football games and basketball games, and unfortunately the baseball and soccer, that is not occurring right now. When you're out there making all that loud noise to cheer on your team, that's part of it. That 7 o'clock alarm clock that goes off in the morning that sometimes we dread to hit makes noise to wake you up. And then obviously, as earlier we were talking about Taylor Swift, got to have our music produced to the radio. So another little example of showing you this actually works is we're going to use some wrap, any kind of container. Since I'm terrible at ripping off of that thing, I'm just going to cut it. And what you're going to do is you're going to put this over any type of bowl, container, anything that you can make it nice and tight. The point of this is to get it as tight as possible. Okay. So the next thing is you want to put a substance on there that's not too heavy or too dense that you can put on and make it move. Now, I just crushed up some candy earlier because I forgot my sprinkles at home. So, like I said, you can use anything. You can even use dirt if you wanted. That'd be pretty easy to do. So, as I get it, you notice that I can make it move through vibrations. My actual contact with it, I can blow it and make it move. But I want to do something with sound. So, what I'm going to do is all I'm going to do is take a pan, which makes noise, and you're going to get up near it, and you're going to hit it. But if you notice, I'm not making contact at all with the container or the table. All you have is the actual sound waves that are occurring right now and causing that to vibrate. The more I do it, the harder it gets. You can also do this with different jars, maybe deeper containers to bang up against to help make the noise so you can actually make the bigger substances bounce a little bit. Just a few little different things to do. So that's one way of doing it. Another great example of showing sound waves is filling up cups full of different types of water, and they'll actually produce a different sound from it because of the actual container water in the size of the glass or the shape of the glass. So checkpoint. I got 5 questions to kind of go with this. So if you're in my class right now for my virtual learning, one of my assignments throughout the week is to do an RSU assignment and go with it and answer some questions to go around it. Good way to get some actual knowledge outside of the classroom and from a lot of different teachers. So question number 1, what form of energy is produced by musical instruments? Think about this. Sound, correct? We just talked about it. If you use your musical instrument, you're going to make a beautiful sound, especially if you listen to the YouTube video of our band playing. Awesome sound. Now, question number 2. Identify and describe 3 different forms of energy found within this room. So in this room, the room that I'm in currently, like I said earlier, you had an amazing teacher show you how to cook these awesome snickerdoodle cookies. She had to use a type of energy for that. She had to heat them. So she used thermal energy. Well, we have lights going on in here. There's radiant energy producing right now. And then, of course, my smart board is playing, and it has to have electrical energy. Those are just a couple different types of energy. Question number 3. Is it possible for an object to use or contain more than one form of energy? I give an example of this. Yes, with the match. You have chemical energy, which produces thermal energy. That's 2 different forms. Your phone, also the same thing. You're going to have electrical energy in there, electromagnetic energy. You're going to use different forms off of one item. So question number 4. What forms of energy are used by a flashlight? Depends on the flashlight, right? If you have battery power in it, if you have batteries in it, you're going to have potential, electrical, and radiant, because it's going to produce a light. Now, I also have a few in my classroom over there, which we can't really get to right now, but we have a few that you actually have to shake to produce the energy within it, which also is electrical magnetic because it has ports in there that you bar up and down with the magnets to cause it. So it has multiple forms just in one flashlight. So depending on the flashlight you use will depend on what forms you have. So question 5. Which form of energy do you believe is the most important for survival and why? 5 minutes? Oh, that's wrong. I was actually hurrying because I thought that was okay. So this one's up to you. Now, again, depending on what you think will be survival. Now, for me, I like chemical or thermal just because I like to have a nice hot house when I'm home in the winter, and I like to cook my food. So those would be 2 really important things for me. But if you would say lived in a country like India, you might say that nuclear energy is more important because a substantial amount of their actual power comes from that. And especially earlier when I said that the world's producing about 150 new power plants connected to nuclear energy, India is actually producing about 40 of those because they actually have a very large population and they need it. So that was the end of my PowerPoint, which we had a roller coaster video to go with it at the beginning just to kind of liven things up and get us started. But in saying that, technical issues didn't work. So that'll be okay. So what I would like you to do is around your house, see what different types of energy is being used. Maybe even have your mom or dad find some YouTube videos online and construct some new energy sources that you do yourself. Figure out just from new sources of what they're actually producing. So if you create elephant toothpaste at home, what's going on? What is it producing? What is it using? If you're going to create these, make sure you have a parent at home. Make sure you are always very clean. Because earlier, like I said, especially if you're using like the glow sticks that I was using earlier, you do not want to get this anywhere. If you get this where it stains, it's not a very good thing to use. So, I don't got much more to say. That's about it. How much more time do I got? That's all he told you? So, huh? Okay. Well, unfortunately, that's all I got today. We had a few technical issues to start, which unfortunately didn't start our video off the right way. But we got one more week next Tuesday. So, especially my students, send me some emails or post on our Google Classroom on what we should do next week so we can entertain for the last and final shot of the RSU TV for me, for middle school science. Well, I hope you guys have a wonderful week. Enjoy this beautiful weather after today. Get outside. Enjoy that nuclear energy. Have a great day.